Hello everyone, I am Soros Pandey. This is SQL Depository and you are watching module number 4 of Postgres Administration. In the last video, we have deployed an AWS Ubuntu VM and in this video, we will try to understand the architecture of Postgres. You may already know that Postgres is a RDBMS and it uses client-server architecture. What is client-server architecture? You will understand in the next slide. It is process per user model and the default port is 5432. This is completely configurable, so you can use any other port if you want. And this is the detailed architecture of Postgres, in which you have the client which requests for the data or which request for the connection. And Postmaster is the process which will receive this request first, and it will authorize and authenticate the request. Now, once the authorization and authentication is done, it will create a Postgres process. This Postgres process will connect with the shared buffer, and suppose for an example, client has requested for the result of select query. So for this, it will get all the required data pages from the data file in the disk into the shared buffer, and then it will serve for the request. Now suppose in your select query, you have an order by clause. And if the data is not already in that order, then it will have to reorder the data. For this, it will need some extra space in the memory to reorder the data, but that space will not be given from the shared memory. It will come from this memory buffer, which is work memory buffer. Now, once the data is sorted, it will render the data. So this is about the select query, but what if you have a request for an update or a delete or any other DML operation? In that case, it will also write the logs, and these logs will be written in the Wal Buffer file in the memory. And in every 5 minutes, it will get synchronized with the disk file, which is here. Now, it is not mandatory that it will get synchronized in 5 minutes only. If the Wal Buffer is occupied and completely full, then it may get synchronized before 5 minutes as well. But it will not go beyond 5 minutes. Then you have a couple of other buffers like maintenance work memory buffer, which is here. And this is the memory allocated for the maintenance operation like the vacuum operation. Then you have Clog Buffer, which is nothing but commit log buffer, and it holds commit log pages. It keeps the track of all the transactions commit status. So this is the buffer that tells us if the transaction has been completed or not, it has been committed or not. Then the last buffer is Temp buffer, which is for the temporary tables. Then we have already discussed about one process, which is Postmaster process. But there are a couple of other processes which are stats collector, check pointer, auto vacuum launcher, logging collector, Wal Writer, BG writer. And if it is enabled, then you also have an archiver process. So stats collector, it collects the information related to your instance. So these are the internal informations. Then you have the check pointer, which release the checkpoint, and in the when the checkpoint will be releases, the buffer files will get synchronized with the disk files. Then you have auto vacuum launcher, which will defragment all your bloated tables. Bloated tables are nothing but fragmented tables which has lots of space, so it will release all those space, it will defragment the table. So this is exactly what this process does. Then you have logging collector, which will collect the log and mainly the error logs related to your instance. And then you have Wal Writer, which will write the write ahead log buffer file from buffer to disk here. Then you have BG writer, which will write the modified pages or dirty pages from shared buffer to disk. So these are the processes, and this is what they do. And then the last process is the archiver process, which is not enabled by default, But if you enable it, then it will archive your Wal files, which is required for point-in-time recovery. So you may not enable it on the lower environments, but it is very much required in the production environment. The Postmaster process. We have already discussed this process, but let me discuss it again. This is the first process to start, which means whenever you start your Postgres instance, this is the process that comes up first. It validates the connection request and assign process. So whenever Postgres instance will have any request, it will authorize and authenticate the request, and then it will assign a process to it. It is the master of all the other background processes, which means it actually owns all the other background processes that you have seen here. The stats collector, check pointer, auto vacuum, logging collector, Wal Writer, BG writer, or archiver. So if you will stop these processes, Postmaster process will go ahead and start those processes again. Then these are the other utility process that we have discussed. BG master, it write modified data to data files. Wal Writer, it write Wal logs to Wal file. Check pointer, in every 5 minutes, it releases a checkpoint for the buffer to get synchronized with the disk. But if the max wall size, which is a parameter in your config file, if that much of space has been occupied, then it may release a checkpoint before 5 minutes also. Auto vacuum. Vacuum operation on the bloated tables. As we have already discussed, bloated tables are nothing but the fragmented tables which has a lot of free space available and the data is fragmented. So auto vacuum will go ahead and defragment those tables. Then you have a stats collector which contain the instance activities. So I will cover this in the next videos where you will get to know more about it. And then you have log writer which write error logs in the log file. Then archiver process, when enabled, it moves the Wal files into archive path. So these are the buffers and process that you must know in order to work on Postgres instance. And this is pretty much about the Postgres architecture. However, in the next video, I will show you those processes in our Postgres instance. So this is what I wanted to cover in this video. In the next video, we will see these processes in our Postgres instance, and then we will also install a sample database named DVD rental. Thank you for watching this video.